You ever see a piece of AI art and just stop and wonder, how? I mean, really, how does a machine dream up something so incredibly complex, so beautiful, seemingly from absolutely nothing? Well, we're going to dive into how this actually works because the answer, it's one of the most elegant and frankly coolest ideas in all of modern AI.
Okay, just look at this for a second. The detail, the composition, the style, that wasn't painted by a person. It was generated by an algorithm. And the crazy part? It started with nothing more than pure random static. You know, like the snow on an old TV screen? So how on earth did it go from that complete chaos to this?
That is the million-dollar question we are digging into today. The secret is this revolutionary technology called a diffusion model. And the best way to think about it is that it literally teaches an AI to be a sculptor, to see a masterpiece hidden inside a block of digital marble. All right, first up, let's really unpack this core idea. I want you to forget thinking about AI as a painter with a blank canvas. That's not what's happening here. Instead, imagine it starts with a solid block of just random noise, and then it slowly, meticulously chips away all the parts that don't belong to the final image. Now, the official definition here sounds a little dense, but the idea behind it is actually beautiful. So get this. To learn how to create, the AI first has to learn how to destroy. It takes a real picture, adds a tiny bit of noise, then a little more and more and more, over and over, until the original picture is completely gone, just static. And by watching this destruction, it learns the exact steps needed to run the whole process backwards. And that brings us right to how this AI actually learns its craft. You can think of it like a two-step dance, a forward process of total destruction, followed by a reverse process of incredible creation.
Let's break this down. It all starts with the training. The model is shown an image that's being slowly corrupted, step by step, with noise being added until it's just a mess of static. Now, at every single one of those steps, the model has one job, and one job only: predict the exact noise that was just added. It does this millions of times across millions of images until it gets ridiculously good at spotting noise. Then comes the magic, the creation part. We start with a totally new random field of static, and we ask the model to run that whole process in reverse. Step by step, it predicts and removes the noise it thinks is there, slowly but surely revealing a coherent, brand new image out of the static.
And this is so important to understand. The AI isn't a collage artist. It's not just cutting and pasting bits of photos it's seen before. No, it's learning the fundamental rules of what makes an image an image. It's like it's learning the grammar of pixels, the deep principles that separate a picture of a cat from random noise. So why do we call this a revolution? Why was this such a massive deal? Because this new method, it didn't just appear out of nowhere. It solved some huge problems that had been holding back AI art for years. And this timeline just perfectly shows the speed of that revolution. I mean, look at this. The core idea was actually proposed way back in 2015, but it was really just a theory. Then, boom, 2020, a breakthrough paper shows it can beat the reigning champ at the time, GANs. Just 2 years later, it's in all of our hands with tools like Stable Diffusion. And now, we're already seeing it generate not just still images, but coherent video. The acceleration is just, it's mind-blowing. You see, for years, the top tech was something called GANs. They worked by having two AIs basically fight each other. One was a forger trying to make fakes, and the other was a detective trying to spot them. It was powerful, but it was famously unstable and super hard to train. Diffusion models are totally different. Their training is more cooperative, more stable. It's a gradual, careful refinement, which leads to way higher quality and more diverse images. Yeah, they're slower, but the results, they pretty much speak for themselves. And hey, that's not just my opinion. As the research points out, it is this step-by-step refinement that leads to such high-quality, coherent images. You know, it's the difference between trying to build something perfectly in one single shot versus building it carefully, piece by piece. So what does this breakthrough actually mean for us, for creators? Well, it means we've all been handed a brand new, incredibly powerful creative toolkit. And that toolkit is already full of specialized instruments. You got Stable Diffusion, which is the open source workhorse that anyone can use and modify. Then there's Midjourney, kind of the artist's choice, known for its stunning, super stylized outputs.
You've got DALL-E 3, which is just incredible at following really specific and detailed text prompts. And then there's something like Adobe Firefly, which is built from the ground up to be brand safe and plugs directly into professional creative software.
And listen, this is not just about making cool pictures from a text prompt. The exact same core technology can be used for editing photos, for upscaling low-res images to high-res, for creating video, even for synthesizing audio. It is a wildly versatile framework. Okay, but all this power, it comes at a cost. Creating a masterpiece from chaos is not easy, and it is definitely not free. We really have to look at the challenges here. To put it in perspective, think about this. To get that one perfect image, an early diffusion model might have to run its little denoising process over 1,000 times. Now, modern tricks have cut that down a lot, but we're still talking about a massive amount of computation. And that high cost leads directly to all the other major drawbacks. It's expensive to run, which means it's slow, and it eats up a lot of energy. Training these models in the first place requires gigantic data sets and thousands of hours on supercomputers. It's just a really resource-intensive process, top to bottom.
So, with all of that in mind, let's zoom out for a second. What's the big picture here? What's the ultimate point of all this amazing, expensive, complicated technology?
The end goal, it's not really just to make pretty pictures. It's to teach a machine to understand the very fabric of our reality, what the researchers call complex data distributions. By learning to create a realistic image of a dog, the AI is actually learning what makes a dog a dog.
And that is the key takeaway here. This is not just a clever trick. Diffusion models represent a fundamental shift in our ability to teach machines. We have given them a framework to find the signal in the noise, to create intricate, beautiful order from pure, unstructured chaos. Which brings us to one final, fascinating question. For all of human history, we've thought of creativity as this uniquely human spark. But if a machine can learn the very process of creation, of sculpting art out of pure randomness, what does that mean for our own role as creators? That is really something to think about.